Hey everyone, welcome back. Today we're going to continue talking about waves and mechanics. This is still part of Unit 1, and we're going to switch around the order. So if you notice some of the quick check numbers are changed around that starting order, that's because we're going to switch around the order of the topic we're going to cover material. We're going to move into superposition next. This is going to be kind of part 3. This is going to be somewhere between a 10 and 15-minute video, so be expecting this maybe broken into 2 or 3 big pieces. We'll sort of see how long it takes us to get through it. But the goal is to make these into shorter pieces that you can watch and easily download if you're having trouble with your internet. Okay, so like I said, this is superposition and related to waves, and this is going to be the first part of section 3. So there's going to be just a series of short PowerPoints. I will be posting the PowerPoints also online, but I will not be giving you the answers to the concept questions in the online version. You'll have to watch the videos to find those out. Okay, so for principal superposition, it's pretty straightforward. You can imagine having 2 pitching machines pitching balls at each other. And if we had something like baseballs that are hard and solid, the 2 balls would collide and ricochet off each other, and their paths would change. Okay, on the other hand though, if we have sound waves, I have 2 speakers set up, both listeners can hear both sets of sound waves. They're going to pass through each other undistorted. Okay, so what the principle of superposition says is if we have 2 or more waves and they are simultaneously present at a single point in space, the displacement in the medium at that point is the sum of the displacements to each individual wave. So all they're saying is if we have 2 waves at the same place, we simply add them together. If they're both going up, we get something that is larger going up. If one is going up and one is going down, then they're going to cancel each other out. That's all there really is to the principle of superposition. This means we add up the amplitudes at whatever point they're at. Okay, so let's take 2 arbitrarily but simple waves. Okay, and we have wave 1, this triangular looking thing, that is moving at 1 meter per second to the right. And we have the second wave, looks like a box. Okay, and it's moving 1 meter per second to the left. And then if we look 1 second later, the triangle wave has now moved over 1 spot. So I think the easiest way to figure out these waves is I pick a distinguishing point on the wave. I might pick the leading edge here at x equals 2. I might pick the trailing edge at x equals 0, or I might pick the midpoint. You have to decide on each wave what's the easiest point. And then 1 second later, so in 1 second, it will travel 1 meter per second, which means it moves over 1 second. So take this leading edge right here, so it's at 2. 1 second later, it's going to be at 3. Okay, the box on the other hand is moving to the left at 1 meter per second. So let's take this edge right here at 4. 1 second later, it will move over 1 spot. So now this leading edge is right here at 3. Okay. If we go another second over, this leading edge of the box will have moved over from 3 to 2. And our triangle's leading edge here that was originally at 3 is now at 4. But as they start to overlap, we're going to add them together. So we're going to take the value at 2 from the first one. We're going to add it to the value of the second one, which in this case is going to be 0 and 1, which gives us still just being at 1. Now the midpoint, on the other hand, the triangle one is up here at 1, and the box is at 1. So we add the 1 and 1 together, we get a 2. At 4, x equals 4, our triangle's back at 0, our box is at 1, we add those together, we get 1. So you can see we get the 2 shapes added together. Okay, now 1 more second. So this box is at 4 is now at 5, and the triangle that was at leading edge at 4 is now at 5. So our triangle is now sitting here, and our rectangle though that was sitting at 2 and 5 is now sitting at 1 and 4. So we're going to do the same thing. We're going to add up all the points. So in this region between 1 and 3, the x value is, or the triangle's value is 0. So we're adding a 0 to the 1, so we get something looks like the rectangle at the top. Now we have this half triangle. We're going to add this half triangle to the rectangle. So we simply pick up this half triangle, we put up above, And now we have this weird, awkward kind of shape that has like an upward triangle for half of it. But now once we get past 4, there is no more rectangle there. And so we have just this lower part of the triangle that adds together. Okay. 1 second later, the two things have moved past each other. Okay. Now, this kind of interference is what we call constructive interference. This is when both waves are either positive or both waves can be negative, but they add together and their amplitudes increase. Okay, so we're going to get a larger amplitude than we had originally for constructive interference. Okay, in this case, both things are bigger than what it would have been initially. Destructive interference, on the other hand, is when we are essentially kind of like, think about this, destructive is destroying the amplitude. So this will happen when you have one that's positive and one that's negative. And so when they add together, they start to cancel each other out. Fully destructive we'll actually find has 0 amplitude. Okay, so same thing. Now we have a triangle pointing upwards here, triangle pointing downwards. They're each moving at 1 meter per second in opposite directions. So 1 second later, this upward triangle is now going to be sitting between 2 and 4. 2 and 4. The downward pointing triangle is between 4 and 6. Moved over 1, so it's now between 3 and 5. So when we add these together, right here at 3, we're going to have one that's at 1 and one that's at 0. And at 4, we're going to have one at 0 and one at -1. So our waveform is going to be like a sharper angle. And it's going to come up to 1, and then it's going to drop down to -1, and then continue on its way. 1 second later, the upward triangle and the downward triangle are lined up. So at each point in space, when we add them together, we're going to get 0. Okay, so essentially they're mirror images of each other and they cancel out. The 1 second later, our upward pointing triangle is now, instead of being at between 3, what is that, 3.5, sorry, that was a half second later. The next half second later, these will move on so that this one is sitting at 3 and sitting at 5. And so here, we're an upward triangle and a downward triangle. We're going to add them together. So we have this region here where the upward triangle has no contributions. We have just the downward triangle's contribution. Then we have this region here where we're going to add together each point up to here. Once we reach 4, from 4 to 5, we only have the upward triangle's contribution. And then after that time, the two waves that pass through each other, they continue on their merry little way, and they won't interact with each other anymore. Okay, so the big idea on interference is the two waves go through, they interact, but they don't lose any information. And when they're done interacting, they're going to wind up coming back and being just the waves by themselves, again, just like they were originally. Okay, so let's try an example. Okay, we have two waves coming towards each other. And what I want you guys to do is to take a moment and pause the video. Okay, and I want you to figure out on your own which answer it is. Okay, and write down your answer on your sheet of paper. So go ahead, take a moment and pause it and figure out your answer. Okay, hopefully you have restarted your video. If you are working with a buddy, I would like you to pause your video again and talk to your buddy about what you chose and why. If you did not, then just hold tight a moment and we'll go through the solution as a class. Okay, so I'm going to switch this over to the document camera so we can go through this as a group. So first question is going to be, what is our time? In this case, t is equal to 3 seconds. So each wave is going to move 3 seconds over. So if I sketch this, sorry, if you can see that, 0, 1, 2, 3, 4. 4, 6, 7, 8. This first wave will move 3 seconds. So this, when it's here at 2, is going to go over 1, 2, 3 seconds over. So my leading edge of my triangle is going to be at 5 at t equals 3. 3. And the trailing edge is going to go from 0 to 1, 2, 3. So it's going to be a 3. And my amplitude is 1. So I'm going to have one triangle sitting right here. Okay. The rectangle is going to also move over 3. And so the leading edge is going to go from 6 over 3 is going to be 1, 2, 3. So it's going to be sitting here at 3 also. The tail edge is going to go over 3, so it's going to come at 5. So in this case, we're going to have a rectangle that is sitting on top of my triangle. So what I want to do is I want to take these two values and I want to add them together. I'm going to choose another color that hopefully will show up okay. So here at 3, okay, I'm going to have a 0 and a 1, so add a 0 and I'm going to get a 1. Over to 4, I'm going to have a 1 and a 1, so that's going to add up to a 2. At 5, I'm going to have a 0 and a 1, which is add up to 1. Which means my waveform is going to be this pink line. It's going to look like a house. So if you said the answer was C, you are correct. All right, so the answer on this one is C. It should look like a house. Okay, let's try another one. So take a moment and read this one and pause your video again. Write down your answer. Okay, if you have a buddy, go ahead and pause the video again and discuss your answer with your buddy. Okay, welcome back. So we are going to go back to the document camera and look at this question. So this one is 17. We're going to do the same thing we did last time. Okay, we are going to redraw our line. We're going to figure out where each one is relative to each other. So make sure you are doing this with me. It's important that you try it in order to have this make more sense. So our triangle, we said it's going to go over t equals 3 seconds. So our triangle's going to move 3 spots. So we're going to go leading edge 1, 2, 3. So it's going to be at 5. The back edge is going to go over 3. So it's going to be at 3. This is going to be downwards 1. So we're going to get something like this. The rectangle, on the other hand, is going to go from 6 and 8 over 3. So this would be 3 and 5. So we're going to be 3 and 5. And now we're going to add these two together. So you have to be a little bit careful in this one. Okay, so we're at 3. I've got a 0. And I've got a 1. So we're going to add 0 and 1 together. We're going to get 1. When I go over to 4, I'm going to get a negative 1 and a positive 1. Negative 1 plus positive 1 is 0. At 5, I'm going to get a positive 1 and a 0, which is going to give me positive 1. And then add those three together. So I'm going to have it come up to 1, go down to 0, back up to 1, and back to 0. Okay. If we look at our pictures, that best matches answer B. The answer on this one is B. All right, so we are pushing the 15-minute mark. So we're going to go ahead and pause this video here, and I'm going to start a new video picking up right where we left off.